Long before humanity could photograph itself, before polished glass, before perfectly flattened metal, there was only water. Picture it. Thousands upon thousands of years ago, our ancient ancestors were wandering through dense, untamed landscapes. And for most of their lives, they had absolutely no idea what they actually looked like. Think about how wild that is for a second. They could recognize every single member of their tribe. They knew the face of every predator hiding in the brush. They could map out every constellation glowing in the night sky. But their own faces remained a complete and total mystery. They could only catch these brief, watery, fragmented glimpses of themselves in quiet rivers, still lakes, and dark pools. And even then, only after the wind had completely died down. It was this fleeting, incredibly fragile image, something that could be instantly shattered by a single raindrop or just a passing breeze. But in those quiet, prehistoric moments of looking down into still water, a profound curiosity was born. It's the absolute beginning of a human fascination that would go on to span millennia, cross entire continents, and eventually push the very boundaries of chemistry and physics.
What do I really look like? It is such a simple foundational question, yet that one simple question slowly changed civilization forever. It sparked what was essentially a technological and cultural arms race to capture, stabilize, and perfect our own reflection. So how exactly did humans create the very first mirror? How do we transition from kneeling in the mud on those riverbanks to standing in front of the flawless, crystal-clear panes of silvered glass that we check every single morning? And why did this obsessive, relentless pursuit of seeing ourselves entirely alter the course of human history, art, and science? In this documentary, we are going to trace the complete, incredible narrative of the mirror. We're going to explore how humanity learned to see itself and how that one invention changed absolutely everything.
Part 1. Nature's Darkest Mirrors, the Stone Age Reflection.
To find the world's first true manufactured mirrors, we actually have to look toward violent, smoky, volcanic landscapes. We're talking about obsidian. Obsidian is a naturally occurring volcanic glass, and it's formed when felsic lava, which is a specific type of lava that's highly rich in lighter elements like silicon and oxygen, cools incredibly rapidly. In fact, it cools down so incredibly fast that mineral crystals simply do not have the time to form. The result of that rapid cooling is this hard, brittle, completely amorphous structure that fractures with these terrifyingly razor-sharp edges. But if you take that dark, jagged volcanic glass and you sit down and rub it with sand, water, and softer stones for days or even weeks on end, something truly magical happens. The earliest known archaeological evidence of people doing exactly this comes to us from Anatolia, which is in modern-day Turkey, all the way back around 12,500 BC. These early Stone Age societies were taking raw black volcanic stone and painstakingly, manually, polishing it into the world's first manufactured mirrors. Now, the reflections they produced weren't like what we have today. They were dark, they were smoky, they were shadowy. It was almost like looking at a ghost of yourself. But to a Stone Age human, holding a solid physical piece of stone in your hands that actually reflected your own eyes right back at you, that must have felt like absolute magic.
When we zoom out for a second and look at the grand timeline of reflective materials, we can really start to see the vast, staggering evolutionary leap of this technology. We start all the way back in 12,500 BC with those dark, shadowy Anatolian obsidian mirrors. Then we see a massive leap forward to 2900 BC, where the Egyptians begin polishing solid, heavy bronze. Fast forward again to the 1st century CE, where the mighty Roman Empire first begins to experiment with transparent glass. Jump to the Renaissance in the 16th century, where Venice absolutely dominates the globe with their brilliant yet highly toxic tin mercury mirrors. And finally, we land in 1835 CE, which marks the dawn of the modern, chemically silvered mirrors we know today. This historical timeline is not just a list of dates. It visually maps out humanity's endless, burning desire for clarity. Every single step on this timeline represents a distinct era where our ancestors looked at their blurry, flawed reflections and said, "No, we can do better." It shows us exactly how the simple, driving desire to see ourselves clearly fueled thousands of years of material science and technological innovation.
Part 2. The Bronze Age Shine. Copper and Bronze Mirrors.
As humanity finally mastered the art of smelting, we entered the Copper and Bronze Ages, and the mirror evolved with us. Artisans, stretching all the way from Kerma in ancient Nubia to the Kijia culture in China around 2000 BC, mastered metallurgy to create these highly revered, stunning artifacts. They literally pulled raw metal from the earth, melted it down in roaring fires, and shaped it into what we call first surface mirrors. This simply means the reflection you see comes directly off the flat, plain, and highly polished surface of the metal itself, which was usually copper or bronze. And the backs of these mirrors? They were often breathtaking works of art, featuring deeply intricate cast relief decorations of gods, flowers, and animals. But you have to understand, these were far more than just everyday vanity tools. They were ultimate luxury status symbols and incredibly deeply religious items. In Egypt, they were actually buried with the dead as vital grave goods. Meanwhile, the ancient Chinese believed that bronze mirrors literally stored up sunlight and could therefore guide the deceased safely through the dark underworld. But they had one massive, unavoidable flaw. The metal tarnished rapidly the moment it was exposed to the air. So to keep that beautiful, warm golden reflection, ancient people had to constantly, obsessively polish them. It was a never-ending chore.
Now, the actual physics behind what those ancient metalworkers were accomplishing by hand is just fascinating. To make a functional mirror out of a rock, you need to achieve a property called specular reflection. Think of it this way. Light acts as a wave, and when it hits a flat surface, you want those waves to bounce back in an equal yet opposite direction without scattering everywhere. For a physical surface to actually do this, its texture, and we are talking about its microscopic roughness here, must actually be smaller and smoother than the physical wavelength of the incoming light itself. Just pause and think about the sheer, grueling manual labor required to achieve that. These ancient craftsmen essentially had to beat, grind, and polish solid copper and bronze by hand for hours upon hours, until the surface was literally smoother than the microscopic wavelength of light. It is an absolutely staggering achievement of ancient engineering and human patience.
But as we all know, humanity is practically never satisfied. Regular bronze scratched way too easily and oxidized incredibly quickly, which constantly clouded the reflection. So ancient metallurgists did what they do best. They innovated. They discovered that by altering the core chemical recipe of the bronze, specifically by adding much higher quantities of extremely expensive tin, up to around 30%, they could create an entirely new, specialized alloy. This became known as speculum metal. Now, this high tin alloy was incredibly hard and actually quite brittle, which made it a nightmare to cast properly. But man, it polished exceptionally well. It provided a much brighter, much whiter reflection than standard bronze ever could. And crucially, it tarnished much, much more slowly. Variations of this speculum metal were used in China for over 2,000 years. In fact, it was so incredibly effective at reflecting light that centuries later, it would be the exact same metal used to build the mirrors in early modern telescopes.
Part 3. A glimpse through glass. The Roman innovation.
Shifting our focus to the glowing, blistering furnaces of the Roman Empire, we get to witness the birth of something truly revolutionary. The 1st century CE marks a critical, monumental turning point where soda-lime glass production was heavily refined. But crucially, this is when the technique of glass blowing was developed. You see, for millennia, glass had been this dark, opaque, muddy material full of impurities. But suddenly, skilled artisans could take a glowing glob of molten glass, blow it into hollow spheres, cut them, and flatten them out into wonderfully thin sheets. For the very first time in human history, there was a material that was perfectly smooth, completely transparent, and practically immune to scratching or tarnishing. It was, quite literally, the perfect canvas for a reflection.
The famous Roman scholar Pliny the Elder actually wrote about this fascinating leap in technology. He claimed, with great excitement, that artisans in the ancient city of Sidon, which is in modern-day Lebanon, were producing incredible new glass mirrors. They were doing this by taking these brand new glass sheets and painstakingly coating the back of them with lead, or even pure gold leaf. The metal backing provided the actual reflectivity, while the glass in front provided a tough, protective window to look through. However, it is really important to note that while Pliny wrote enthusiastically about these early glass mirrors as if they were everywhere, the archaeological evidence tells us a slightly different story. Digs revealed that these items were incredibly rare, ultra-luxury novelties that really didn't become even somewhat common until the 3rd century.
So, you might be wondering, why on earth did it take so long for glass mirrors to catch on? Well, when we actually compare the two materials side by side, the glaring flaws of the Bronze Age versus the fragile, risky promise of early glass become totally obvious. Bronze mirrors, as we mentioned, were first surface mirrors. They were durable, heavy, and practically indestructible. You could literally drop a bronze mirror in the dirt, pick it back up, dust it off, and it was perfectly fine. But they scratched easily and required exhausting, endless polishing. Early glass mirrors, on the exact other hand, applied the reflective metal to the second surface, meaning the back of the glass. The brilliant, game-changing innovation here is that the hard glass perfectly protected the soft metal backing from scratches and tarnish forever. No more polishing. But the trade-off was absolutely brutal. These early glass mirrors were incredibly fragile, usually very tiny, and wildly expensive to produce.
One accidental slip of the hand and your priceless, ultra-expensive mirror shattered into 1,000 useless pieces on the floor. Because of that immense risk, for centuries, most of the world just stuck with polished metal.
Part 4. The Venetian Secret, a monopoly on reflection.
To see glass mirrors truly rise up and conquer the world, we have to transport ourselves to the romantic, canal-lined streets of Renaissance Venice. The master glassmakers isolated on the island of Murano guarded a highly lucrative, closely kept secret that would eventually make Venice the absolute, undisputed center of European luxury. First, they perfected a recipe for an ultra-clear, highly refined glass that they called cristallo. It was so pure it looked like flawless rock crystal. But their real, ultimate secret was a highly toxic fire gilding technique used to make the mirrors. They would carefully lay down a microscopically thin sheet of tinfoil, bathe it in liquid mercury to create a chemical amalgam, delicately slide that perfectly flat cristallo glass over it, and then gently heat the whole thing to evaporate the mercury. The end result was a flawless, dazzlingly bright, brilliant mirror. And they even figured out how to make them massive, scaling up to an astonishing 40 inches square. But there was a horrific downside. The mercury vapor released during heating was incredibly toxic, slowly and painfully poisoning the master craftsmen who dedicated their lives to making them. Yet the global demand was simply insatiable. These mirrors quickly became the ultimate European luxury item, mounted in richly decorated, gilded frames in sweeping palaces across the entire continent. They were so obscenely expensive that in the late 17th century, the French Countess de Fiesque famously traded an entire working wheat farm just to purchase one single Venetian mirror. And the craziest part? She famously bragged to her friends that she actually got a bargain.
But as history shows us time and time again, a monopoly that lucrative simply couldn't last forever. The Venetian state was so terrified of losing their cash cow that they literally forbade its glassmakers from ever leaving the island of Murano, under strict penalty of death, just to prevent the secret of the tin mercury amalgam from spreading. But the French monarchy, who were bleeding vast, unimaginable amounts of gold to Venice just to decorate their lavish palaces, finally decided enough was enough. What followed was a dramatic, high-stakes game of 17th-century industrial espionage. French agents secretly infiltrated Venice and smuggled master Venetian mirror makers out of Italy under the cover of darkness. Once safely in France, these defectors helped establish massive domestic workshops. And the French didn't just copy the Venetian technique, they industrialized the whole thing. They developed completely new ways to cast much larger plates of glass and mass-produce the silvering process. This bold move eventually broke the Venetian monopoly entirely and kicked off the long, slow process of making mirrors affordable to the broader public.
When you look at this complete narrative arc, it reveals a fascinating, relentless escalation of clarity. Think about it. Every single civilization managed to brilliantly solve the previous era's fatal flaws, but in doing so, they simultaneously introduced entirely new, unforeseen challenges. The Stone Age obsidian finally gave us the very first reflection, but it was dark, brittle, and incredibly small. The Bronze Age solved that by giving us durable, moldable metal, but those reflections were warm-tinted and constantly tarnished in the air. The Renaissance solved the tarnish problem by bringing us the tin-mercury amalgam, yielding incredibly clear, brilliant glass mirrors, but at the absolute horrific cost of highly toxic mercury vapor that literally killed the artisans making them. Humanity was pushing relentlessly toward perfection, generation after generation, but to finally achieve a truly safe, pristine reflection without the deadly side effects, we were going to need a completely new kind of science.
Part 5. The Silver Revolution. Chemistry changes everything.
Moving completely out of those sweaty, toxic artisan workshops and into the sterile, precise laboratories of the Industrial Revolution, we find that the year 1835 is the exact moment humanity forever changed how it sees itself. A brilliant German chemist named Justus von Liebig stepped into his laboratory and managed to invent the modern silvering process. Through sheer scientific ingenuity, he found a way to chemically deposit a microscopically thin, flawlessly even layer of pure elemental silver directly onto a pane of glass. It was a monumental breakthrough that completely and entirely bypassed the need for toxic mercury and intense heat. In one stroke of genius, Liebig democratized the mirror once and for all.
Here is exactly how Liebig accomplished this absolute magic. It's essentially a variation of a famous chemical test known as Tollens reagent. First, you carefully prepare a specific, perfectly clear liquid solution of diamine silver I1. Second, you take that solution and mix it with a simple reducing agent, something as basic as sugar.
Third, you spray or pour this wet, clear mixture directly onto a perfectly clean, pristine sheet of glass. And fourth, the chemistry simply takes over. The silver ions in the liquid oxidize the sugar, and in doing so, they reduce themselves into pure elemental silver. As that liquid just sits there on the glass, a brilliant, solid silver mirror literally materializes right out of the clear water, bonding directly to the glass surface in a perfect, flawless layer. No fire, no toxic mercury vapor, just incredibly elegant chemistry. This wet process allowed mirrors to be mass-produced safely and cheaply on an industrial scale. This meant that for the first time in human history, regular, everyday people could actually afford to see themselves perfectly clearly in the comfort of their own homes.
But the evolution certainly didn't stop in the 19th century. While wet silvering is still used today for certain applications, today's modern household mirrors, the ones you have in your house right now, are overwhelmingly made of aluminum, using an incredibly high-tech process called vacuum deposition. Today, automated production lines take enormous, flawless sheets of glass and place them inside giant, sealed vacuum chambers. Inside those chambers, electrically heated nichrome coils get so incredibly hot that they literally vaporize solid aluminum wire into a gas. Because it's happening inside a vacuum, there's no air to get in the way, so those extremely hot, vaporized aluminum atoms travel out in perfectly straight lines, hitting the cool glass surface and instantly condensing to form a tough, precise, brilliantly reflective microscopic layer. A final layer of protective paint goes on the back to seal it all in, and boom, that is the very mirror you look into every single morning while brushing your teeth.
Part 6. Mirrors Beyond Earth. Seeing the Universe.
Humanity's ultimate mastery of the mirror didn't just change how we look at our own faces. It completely transformed into our most powerful scientific instrument. By learning to curve the glass into incredibly precise parabolic shapes, scientists realized we could concentrate parallel rays of light into intensely hot focal points, allowing us to power massive solar furnaces that can melt steel. We also realized that mirrors don't just reflect visible light, they reflect invisible wavelengths too, like radio waves and X-rays, which completely enabled modern satellite communications and broadcast antennas. But perhaps most profoundly of all, mirrors became our literal eyes into the cosmos. By engineering massive segmented telescope mirrors, like the stunning golden honeycomb structure of the James Webb Space Telescope, which is actually coated in a microscopic layer of real gold for maximum infrared reflection, we are currently using mirrors to capture ancient, impossibly faint light from the very edge of the universe. Over thousands of years, the mirror evolved from a primitive tool of human vanity into an unparalleled machine for deep space exploration.
It is an incredible, almost poetic realization when you really sit back and think about it. Think about the prehistoric human we started this journey with, kneeling in the dirt, peering down into the dark, watery depths of a river just to try and see the blurry, fragmented outline of their own face. And today, modern astronomers sit in high-tech control rooms, peering into perfectly polished, cryogenically cooled mirrors floating a million miles away in the freezing void of space, looking backward in time to see the fiery birth of the very first galaxies.
The history of mirrors is not simply the story of polished glass. It is the story of humanity learning to look at itself. From those quiet, prehistoric rivers, to sharp volcanic stone, to shining bronze, to toxic Venetian workshops, all the way to modern observatories exploring the vastness of the universe. Every single mirror has reflected far more than just our faces. It has reflected our ingenuity, our unstoppable curiosity, and civilization itself. The technology has evolved dramatically, but the deep, burning human desire to look into the dark and see something looking back remains exactly the same. So the only question left is, how far will humanity truly see next? If you enjoyed this documentary, like, subscribe, share, and join Sketchmind as we continue exploring the incredible story of humanity.